I'm Chris Hyde. I'm a researcher at the IESSG at the University of Nottingham, and a lot of the research I'm doing at the moment is on indoor navigation. So this is an IMU. This is an inertial measurement unit. So it contains 3 accelerometers and 3 gyros. So what it tells you is how much the IMU is rotated and how much it accelerates in each direction. So what we do is we add those measurements up to work out the orientation and the movement of the IMU. The trick that we do is we put this actually on our shoe, and then every time we take a step we can say that the inertial measurement's not moving. And through doing that we can maintain very accurate positions even for fairly long periods of time. So it's beginning to get really useful for things like positioning inside big buildings like hospitals or positioning you around airports. What we've got here is someone walking around the building with their IMU attached to their foot. And what you can see here is each individual step that they're taking. So as they walk around, they're lifting their foot up and then dropping it down every time they take a step. And you can actually see that happening in the position plot that they're generating. So here they're just walking up the stairs, and you can see in 3D you can count the steps as they're climbing, and they walk around the lobby and then walk up another set of stairs. The future for this technology, well, we call these low cost, but they're still relatively expensive. But now with things like the iPhone, which really are low cost and have very low cost versions of these sensors inside them, the future is trying to use those and combining them with measurements from other sensors, such as GPS when it's available, maybe Wi-Fi signals when you're indoors. So what we're working on at the moment is a lot of these smartphones now include sensors such as gyroscopes and accelerometers. So gyroscopes measure how much the phone is rotated, and accelerometers measure the acceleration of the phone. And what we can do is we can use those measurements to try and work out, if we know where the phone starts and we move it to somewhere else, it tells us how much we've moved. So what this picture in Google Earth shows you is a pedestrian walking around our university campus. So the red line on there shows you where they actually walked, and all these dots that you can see are the position solution that you actually get from an iPhone. What we've done is we've color-coded the dots, so when it's a green color, it's supposed to be an accurate position, or the phone's telling you that it's an accurate position. And then when you get the blue and the purple colors, that's when the phone's reporting less accurate positions. So what you can see is when the user actually walks inside some of these buildings, you get some very inaccurate positions. And in actual fact, what actually happens is that the GPS from the phone stops working, and you don't get a position inside this building at all. What you can also see is that the position drifts quite a lot. So the user's actually supposed to be walking along this red line, but in actual fact the position shows you that you're somewhere in the middle of this lake here. The kind of things that we're looking at using this for is like a in-car navigation unit, but for pedestrians moving around large buildings. For example, hospitals, telling you where you need to go inside a hospital, being able to direct you to specific rooms, things like airports where you need to be told what gate to get to and how to get there.